Okay, welcome back, class. We are still on endocrine system, and I want us to understand the difference between a negative feedback loop and a positive feedback loop. Okay, so when we hear the term negative feedback loop, most of the feedback loop systems in our body are negative, meaning um, okay, you eat a meal with soda that has sugar, you have pasta which has sugar, you have bread that has sugar, you have rice that has sugar. So let's say you eat a heavy potatoes, mashed potatoes, right, breading. So you have this meal with lots of sugar. So your blood sugar increases. A negative feedback loop is going to coordinate a series of events that try and create the opposite. It's going to try and decrease blood sugar. Negative feedback loop. You're exercising and your heart rate goes up and you start perspiring and breathing quickly. When you stop exercising, a negative feedback loop kicks in and allows your heart rate to come back to normal, allows your heart rate to come back, your breathing to come back, and you're not overheated anymore. You start to cool off. Those are negative feedback loops. Okay. A positive feedback loop is when you bring on more of that same type of physiological response. So when a woman is in labor and a woman is releasing oxytocin, oxytocin is going to make the myometrium contract of the uterus. And when there's more contraction of that smooth muscle of the uterus, the woman experiences more pain, more discomfort. Now, you'd think if you're experiencing pain, some sort of mechanism should kick in to decrease the pain, but that would be a negative feedback loop. So, a positive feedback loop is more oxytocin, more contraction, more pain. More oxytocin, more contraction, more pain. More oxytocin, more myometrium contraction, more pain. And this positive feedback loop keeps on bringing more and more and more of it to bring on the labor, to bring on the delivery. Okay, so that entire process is a positive feedback loop. The only time it becomes negative is after the baby is delivered, of course. Okay, what about another positive feedback loop? In the body, in a blood vessel, we have different layers. We have uh, this innermost layer, we have a smooth muscle layer, and then we have an external elastic layer. So the innermost, they're all called tunica something. So the first layer, the innermost layer, is called the tunica interna. And the outer layer is called the tunica externa. And then the middle layer is the tunica media. Okay, this is smooth muscle. I'm making it like a coil. Okay, now the innermost layer, which is the tunica interna, these are epithelial cells. They're like squamous cells, and they're easily damaged. So if you eat, let's say, high blood sugar, fried foods, lots of salt, lots of sugar, high fructose corn syrup, what ends up happening is you can have damage to some of these cells. That innermost layer, since it's only one cell layer thick, can get damaged. Okay. And what ends up happening is the smooth muscle layer starts to impede and it moves inward into that lumen. Now remember, in the lumen, this is where blood's supposed to be. And you end up in blood, you have cholesterol. So you have cholesterol that moves into to the tissues. Cholesterol doesn't hang out here, despite what most people think. Cholesterol dives deep into the smooth muscle layer over here. So that's where your LDL cholesterol hangs out. But the LDL, the low density lipoprotein cholesterol, gets damaged in that scenario where you had high blood sugar, alcohol, fried foods, lots of salt, alcohol, medications, corticosteroids. They damage that cholesterol. So we'll make this black. So when this becomes damaged, your immune system walls it off. It actually walls it off. Your monocytes, your white blood cells, collect it because it's damaged goods. And when these cholesterol gets walled off, your body will create like this seal. What ends up happening is now this, let me make this, let's make the innermost layer, let's make it lavender here. Now this innermost layer, you got the smooth muscle moving in, and you got all this oxidized cholesterol bulging. Now here's the endothelial layer now. Okay, you see where the lumen, the innermost layer, started out like that, right? Nice and round. Now look at the shape of it. It is very irregular shaped. And remember, blood is traveling through here. So if blood is traveling through here, nice round, it's nice and smooth. When blood is traveling through here, it's very irregular, very turbulent, very jagged. And when you have blood traveling turbulently, your body will think you got shot or stabbed. And if you got shot or stabbed, what your body will do is it will want to lay down fibers like this, called fibrin, because it thinks you got shot or stabbed. It wants to stop the bleeding. So now it starts to create more of these fibers. That's fibrinogen. Remember, positive feedback loop. It keeps doing it and doing it and doing it. It keeps on bringing more of these fibrin layers because it thinks you got shot or stabbed. It doesn't want you to bleed to death. It keeps on doing it and doing it and doing it until what happens? Until a clot is formed. Until a clot is formed. Now, if that was a blood vessel that was going into the heart, and now you got that and it's blocked, you have a heart attack. If it's happening to the brain, you have a stroke. So that's when these positive feedback loops become very, very life threatening, right? They're good when it's in something like pregnancy and labor, but bad in instances of strokes and heart attacks. Okay. Okay. Now, I'll pause here. When we come back, we're going to talk about thyroid and parathyroid function now that we know what positive and negative feedback loops are.